Hello folks and welcome back to more of the 2003 Hypatia paper. I'm Root Beer and we're looking at question number 2. Okay? And just a reminder, this is the written grade 11 level contest put out by the University of Waterloo. So we are going to be writing up our solutions. Okay, question 2 says, Xavier and Yolanda are playing a game starting with some coins arranged in piles. Xavier always goes first, and the two players take turns removing one or more coins from any one pile. The player who takes the last coin wins. So, you can remove one or more coins. I'm guessing you can actually just remove a whole pile. So, we have some examples here, so I assume these are related to, or not examples, pictures, I guess, and they're related to A and B. So what does A say? If there are two piles of coins, with 3 coins in each pile, show that Yolanda, the person who goes second, can guarantee that she always wins the game. Alright, so Xavier might go first, but apparently Yolanda can always win the game when we have 3 piles. Okay. So with something like this, it can be very beneficial if you actually have little aids. You are not specifically banned from bringing anything in particular. I mean, you can bring rulers, you can bring calculators. I encourage people to bring some dice. Cubes come up a lot in these contests, and so little dice can help for probability questions, but also for cube-based questions, just so you have a picture to look at. And coins. I mean, you probably will bring your wallet or your purse to the contest. By all means, get out some small quarters or other thing of currency, and you can actually make 3 piles and try these games for yourself. It's certainly something you can do. That said, you don't need coins to do this, but a nice tactile medium can certainly help, and you can actually play the game one-on-one against yourself in real time. That can certainly be an excellent way to learn about this problem. But I don't have any coins with me. I mean, I have my coin collection up there, but I'm not breaking those guys out just for a math contest. So we're going to have to think things through and sort of draw pictures representing what we think is going to happen. So 2 piles, 3 coins in each. Okay. Well, really quickly, what would happen if we just had 1 coin in each pile? Okay? If you're stumped with a larger case, it's always a good idea to think of a smaller case. And if we just had 1 coin in each pile, then Xavier would take his first turn. He'd remove 1 coin from one of the pile, because it can only be from 1 pile that he removes coins on his turn. Otherwise, he'd just take them all and win. So he takes the coin out of the first column, and then Yolanda has to basically take the last coin. So if we could argue it down to the point where Yolanda can force it to be 1 coin, then we know she'd win. But we start with 3 coins and 3 coins. Okay. Well, what if we had 2 piles with 2 coins each? Okay. And now we're getting to the point where I can't just verbally say this. What if we... Try smaller cases. So this is always a very important thing. Two piles with 1 coin each. So I represent my coins with 2 horizontal lines. X can only take 1 because he's confined to 1 pile per turn, and Yolanda takes the last coin. How about 2 piles? 2 coins each. Okay. And it may be that there is something special about the number 3. You can't rule that out. But basically, at this point, we say, okay, 2 coins, or 2 piles, 3 coins each. That looks, at least to us, like 2 piles, 1 coin each, and 2 piles, 2 coins each. So the thinking is a smaller case where we've just reduced the number of coins in each pile should be similar or analogous or show us part of a pattern that we could use with 3 coins each. That might not be true. It might have something to do with the fact that there are 6 coins overall. But we won't know until we try and we hit a dead end and something that we can't generalize. Okay, now on Xavier's first turn, he has to take at least one. He has to pick a pile. We'll just say it's the first pile. And he has to take either 1 coin or he takes all the coins. Okay? Now, if he takes all the coins, Yolanda can just look at this other pile and she can take everything and win. Okay? But if Xavier only takes 1 coin, well, if she takes this coin, then Xavier can just take this whole pile, this whole second pile, and win. If she takes this whole pile over here, the second pile with 2 coins, then Xavier will take the last coin and win. But what if she just takes 1 coin from the pile that has 2? Then we'll be left with 1 coin in each pile, and we know she wins at this point. Right? This isn't the win condition, but then we're now down to 2 piles, 1 coin each, and Xavier is still going first. Okay. And what it turns out is this will be a simple mirror strategy. Whatever pile that Xavier picks, and however many coins he takes out of that pile, Yolanda on her turn will just pick the other pile and take the same amount of coins. Okay? That way, each time it's Xavier's turn, he'll have 2 identical piles. They'll both have the same number of coins, be it 2, where we know Yolanda will win now, or 1 coin left in each, where we know Yolanda wins again. Okay. So, Yolanda's strategy on X's turn, he takes X coins. And X is always greater than or equal to 1. We were told you can take at least 1 coin, or you could, probably take them all, as long as they're from 1 pile. So on Yolanda's turn, she also takes X coins, but from the other pile. That kind of looks like otter pile. There are no otters here. Okay. So, if we're going to do this, we should explain why this works. Okay? So, if you want to prove something, you need to either write an exhaustive list of all possible cases of what Xavier can do and how Yolanda should respond, or you need to come up with an explanation based on your strategy that shows, you'll only get these cases, and this is the only thing that can possibly happen here. For example, you need to show that if he takes X coins, then Yolanda can also take X coins. Things like that are the things you should be thinking about when you justify your answer. So Xavier is always going to be faced with two identical piles of coins. All right. So he starts with 3 coins in each pile. So he must take at least one. Yolanda also takes X. And so then X, he's looking at 2 piles with 3 minus X in each of them. Okay. So if 3 minus X is 0, then Yolanda, on her turn, she must have taken the last coin. Otherwise, we repeat the process. So then X starts with 3 minus X, 3 minus X. He has to take at least one. Yolanda takes the same number, but from the other pile. And if it turns out at the end X is facing 2 piles with nothing in them, then Yolanda must have taken the last coin. So we see that the only person who's going to win the only person who's going to win is Yolanda. Okay, now what we can do is we can actually take the number 3 out of this. We can say that he starts with n coins in each pile. He takes out at least one. And we know the pile is shrinking. And so at the end, on his next turn, he's also faced with another set of identical ones. So we just make the comment that since X is greater than 1, n minus X is less than n, so the game will end. So the other thing we needed to worry about is, yeah, Yolanda will win in these scenarios, because she's the only one who can take the last coin, but who's to say that a last coin will ever be taken? And that would be true if Xavier could take no coins, if that were possible, but that's not allowed. He has to take at least one, so the piles will always get smaller. There will always be less coins each time we go back to the Xavier starts with 2 identical stacks. You take some number, Yolanda takes the same number from the other pile, and Xavier is once again presented with 2 identical stacks. This time those stacks are less than the stacks he saw last time. Okay? So the game will end. The only person who can possibly win in this scenario, as we stated, is Yolanda. So Yolanda will win whenever we start with 2 piles of N. And N equals 3 is the case for the part A that we're doing. Okay. So we still have a B part to this question, and it involves a little more complicated setup. Now there are 3 piles. There's 1 coin, 2 coins, or 3 coins. Explain how Yolanda can guarantee that she will always win the game. Okay. Now, the work we did in Part A was a much simpler version of the game. We started with N in each, or more specifically, we started with 3 coins in each. So you probably could have actually written out all the possible things that Xavier could have done and the responses Yolanda could have had. And what we did is we generalized a little bit, so we could say that Yolanda wins whenever you start with N coins and N coins. But now we've got 3 piles. It's a little more complex, but hopefully, some of the work we did in Part A will work out. Like maybe, we have 1, 2, and 3. Maybe at some point there's a possibility that Xavier will force the game to be, that Yolanda can force the game to become the 2-2 case. Xavier takes that single coin, and then Yolanda responds by taking a single coin off the 3 pile, and then Xavier is presented with 2 identical piles. So it's possible that our work in Part A will definitely help. But it's also possible that maybe A was just a very easy case to get us accustomed to the problem, and B is much harder and has nothing to do with A. That is possible. So be on the lookout for connections, but don't assume that there are connections. Don't assume that wonderful, elegant proof you did in Part A is going to in any way impact Part B. So 1, 2, and 3, well, maybe we should start exploring this. What could Xavier do? What could Yolanda do? Okay, so we start off with 1, 2, 3. And on Xavier's turn, what could he do? Well, he could take this single coin and then we're left with 2 and 3. And Yolanda could then take the 1 pile, and at that point it's a win for her because she's handing Xavier 2 identical piles. But Xavier doesn't have to take that single coin. He could do something devious. He could take 2 off of the 3 pile. Okay, we're left with 1, 2, and 1. But Yolanda could take all of the middle pile. And now it's the 1-1 case, and we're handing 2 piles with 1 in each in them to Xavier, so Yolanda's going to win here too. Is there anything Xavier can do that Yolanda can't immediately then force this situation? You could take all the middle, but then Yolanda's just going to take these top 2, and we're going to be left with another win for Yolanda. So how can we phrase this? What can we say? So this is just a little bit of experimentation. You wouldn't show your experimentation in a written proof. You would do that on a side piece of paper. So let's get to writing a proof. So Xavier starts looking at piles 1, 2, and 3. We claim Yolanda can end her first turn. So she can end her first turn, giving Xavier 2 identical piles. So 1, 1 or 2, 2. There's no way to get 3, 3. We don't have any 2 piles that have at least 3 in them. So what did I end there on? 1, 1 or 2, 2. So 1, 1 or, and now I need to write 2, 2. So we do use our previous work in A. We showed that 2 identical piles with Xavier playing first means that Yolanda wins. So if we can show, as we've claimed here, that Yolanda at the end of her first turn will hand back 2 identical piles or leave Xavier with 2 identical piles, then Yolanda will win. And that uses the work we already did in Part A. The strategy that we unfolded, the general case, starting with n coins in each pile, which we articulated, that gives a win here. So how do we show this? Well, there isn't a nice, elegant strategy here that I can see. There's just too much variability in what Xavier can do on his first choice. So what we're going to have to do is list out some cases. So Xavier's first turn, you can take from the 1 pile, the 2 pile, or 3 pile. And we're just going to have to deal with these cases. So if he takes from the 1 pile, he must take the whole pile. Because there's only 1 coin in it. So 1, 2, 3 goes to 0, 2, 3. So Yolanda just takes 1 off the 3 pile, and we're left with 2, 2. Okay? We already sort of talked about this, but now we're writing it up, and we've sort of written our own notation. Well, now what if Xavier takes from the 2 pile? Well, he could take... you can take 1, or you can take all. So 1, 2, and 3. You can either take just the 1, so we're left with 1, 1, 3. Or you can take the whole pile, so we're left with 1, 0, 3. So Yolanda takes the whole 3 pile, and we're left with the 1, 1 case. Or she takes 2 off the 3 pile, and we're left with 1, 0, 1, which is the 1, 1 case. Okay. One more thing to look at, the 3 pile. So Xavier now chooses on his first turn, he's going to take something from the pile that contains 3 coins, and we have 3 cases. He takes 1, he takes them all, or he takes 2. So that would leave with 1, 2, 1. Taking them all, would be left with 1, 2, and 0. And taking just 1, we'd be left with 1, 2, 2. So Yolanda is going to respond by taking the single coin here. She takes the whole 2 pile in this case. And she takes she takes 1 off the 2 pile in the third case. Either way, we've argued it down to she leaves him with two identical stacks with 2 coins, or 2 identical stacks with 1 coin. So we've covered all possible cases of what Xavier can do on his first turn. We conclude Yolanda has a winning strategy. Okay. So let's just do a little quick review about what we did in this question. We were introduced to an interesting little game, and I do encourage you, if you had coins, you could have started playing with them. I mean, maybe when you tried these questions, and you should try these questions before you watch these videos, maybe you got out some coins and tried them. And what we did at the very start is we dived in, we looked at some simpler examples because the 3-3 case, there were too many possibilities as to what could be done. So we looked at 2 piles of 1 coin each, trying smaller cases, and we realized, yeah, Yolanda has a winning strategy there. And then we tried 2 piles of 2 coins each. And it was a little more complicated, and we noticed it did in part reduce down to our previous case, but we showed Yolanda can win. And by taking a look at those 2 strategies, we formulated our own strategy that whatever Xavier takes from 1 pile, she takes that same number of coins from the other pile. And then we sort of gave a little bit of a proof, and we used the more general setting of NN. I sort of stuck that in at the last minute because I realized when I had the number 3 in here, there was nothing special about 3. It could have been any number of coins, and it turns out that helped us with Part B. Now, if I hadn't realized it at the time, I could have gone back and rewritten this so that it was more general, and then it was 2 piles with N coins is definitely a Yolanda win. Once I realized the use that 1-1 and 2-2 had in Part B. So in Part B, we, with a little more grasp on the situation, we didn't need to look at different smaller cases. Frankly, it's hard to generalize 1, 2, and 3 to a smaller case. So, a little bit more understanding the game under our belt. We just explored it a little bit and said, hey, Yolanda can always win if she brings it down to the 2-2 or 1-1 case that was so important in the last question. And then we said, okay, we've got an idea, but can Yolanda actually always do this? And we had to do case-by-case work with Xavier. Could he pick the 1 pile, and what could he take out of there? Could he pick the 2 pile, what could he take out of there? What is Yolanda's response? And it turns out that no matter what Xavier does on his first move, at the end of her first move, so the second turn in the game, Yolanda can always leave him with a stack of 2 piles with an identical number of coins, and we know from Part A that is her winning strategy. So overall, I think that was a good question. I think it was a little challenging for Part 2, but for question number 2, but that's all right. And in the next video, we're going to take a look at question number 3, so join me then, and I'll see you guys that time.